Hello, welcome to ANS Solver. This is the third question of the paper. So at a factory A, okay, the mean number of accidents is 32. Okay, so it's the mean. Okay, they have already specified that. At factory B, the records of numbers of accidents before 2018 have been lost. But the number of accidents during 2018 was 21. So it is known that the number of accidents per year can be well modeled by a Poisson distribution. Okay? So use an approximating distribution to test at 2% significance level whether the mean number of accidents at factory B is less than factory A. So now you tell me one thing. They have told you it's Poisson distribution. So you know your lambda is simply 32. They have told you that already. Your test value you know is 21, correct? Because you're testing if factory B is less than factory A, okay, the number of accidents. So you know your test value is also 21, okay? Now, because I know my lambda is equal to 32, my lambda is basically my mean and the variance, okay? This is what I know. So now, to test this, I know my null hypothesis is basically stated as my lambda equals to 32, and my alternative hypothesis is that my lambda has decreased because B is less than A, correct? So now what I need to do is, I know my graph will look something like this, correct? So I can say, I'll tell you how via normal distribution graph also. So my normal distribution graph will look something like this. I know this is less than, so I've told you it's always below the mean if it's less than, if the sign is less than. So that means, and we know that the significance level is 2%. That means the area here, I know, is 0.02 and the area here is basically 0.98. So to calculate the Z value, what I can do is, on the table, I can search for 0.98. So I can go on the table here, correct? If I see, so first 0.98 is not in the critical values. So I'll search here in the table. If I see I have 0.9798 here. So that's basically 2.0 and 5. Okay. So I have 2.05 written here. Got it? But now here I'm missing it by 2. I'm missing 0.98 by 2. So I can look up 2 here, which will give me 4. So my final answer is 2.04. Okay? Easy reading the table. Now, I can't write this as 2.04 because it's less than the mean. So it becomes minus 2.054. Correct? Now comes the important part. They have asked us to use an approximating distribution here. Okay, so what I need to know is, how can I convert a Poisson, okay, to a normal? Okay, where in the normal obviously it's mean comma the variance, so it's lambda comma lambda. So you can only convert from Poisson to normal when there are some conditions. The first condition is that my lambda should be more than 15. Got it? That's the main condition. Okay. And whenever we are converting from Poisson to normal, there's a continuity correction, which you need to keep in mind, which I'll tell you later how to use. So if you see here, my lambda is 32, which is more than 15. That means my Poisson can be converted to normal. So I can write this as my normal distribution basically as n, not no, my bad. So n as 32, 32, because I told you the lambda is the mean and the variance. Got it? So now I use my formula of z star, which is my statistic value, which is the value minus, okay, the lambda over the root of lambda, because we need the standard deviation and my variance is lambda, hence the root of lambda. Now I told you all a continuity correction is needed. So normally when we convert from Poisson to normal, and if the sign is more than, our test value is 21. Okay, so if it's more than that time we do 21.5, but here if you see the sign is less than, so using normal Poisson to normal, we should write this as 20.5. Correct, this is what we should write. But now in hypothesis testing, this works the other way around. If it's less than, correct, then you go the opposite direction. You write this as 21 plus 0.5, which will give you 21.5. If it's less than, that means we need to add 0.5 in hypothesis testing, and if it would be more than, we need to subtract 0.5. Okay, so this is one thing which you need to know. It's a very important concept. So now I know my z star is basically 21.5 minus the lambda, which is 32 over the root 32. So I know my z star is basically, on the calci I can solve this, okay, to get 21.5. So 21.5 minus 32 over the root 32. So the value I get is simply minus 1.8561. Okay, this is what I get. Okay, so now what I need to do is I need to compare the mod of the z star to the mod of minus 2.054, which is basically the mod of minus 1.8561 and the mod of 2 or minus 2.054. So this is basically 1.8561 and 2.054. Okay, so if you see here, this is bigger, the 2.054 is bigger. That means this does not lie in the critical region. So there is evidence, okay, or there's actually no evidence that the mean has decreased. So that means you say, do not reject the null hypothesis, okay, and no evidence of decrease. Or you can say that, factory B is not less than factory A, okay, because you're testing for that. You can say that also. So now what I need to do is, why now many of you might be thinking, if it's less than, then why did I say do not reject? Think about it, graphically. My minus 1.8561, okay, lies somewhere here, okay, but my critical region is here. So my minus 1.8561 does not lie in the critical region. So I can simply say that there's no evidence of decrease. Okay, you can think about it graphically also.